Hi, I'm Bob. We will continue our solutions to the long-run competition today and solve all the remaining problems in this section. During the Thanksgiving holiday, I want to express my gratitude for your love and support throughout the year. I wish you a very happy Thanksgiving with your family and friends. Let's go to exercise 4.6. Derive the residual supply elasticity in equation 8.17 using the definition of the residual demand function in equation 8.16. What is the formula with n identical countries? A country's import supply function is the residual supply function, where SP is the world's total supply and DPO is the demand from other countries in the world. Differentiating the equation with respect to P gives the following expression. Multiplying both sides by P over Q gives the following equation. Multiplying and dividing the first term on the right-hand side by Q over Q and the second term by QO over QO would not change the value. It gives the following expression. Small q is the residual supply in the importing country. Capital Q is the world supply, and QO is the demand from other countries. We define the parameter theta as the importing country's share of the world's supply. Then, lowercase q equals theta times capital Q, and the demand from other countries equals 1 minus theta times the world's total supply. We do this because we want to form the elasticity terms. The left-hand side of the equation is eta R, the elasticity of residual supply. Eta is the world's market supply elasticity. Epsilon O is the demand elasticity of the other countries. So, we can obtain equation 8.17 in the textbook. If all n countries are identical, then theta equals 1 over n. The elasticity equation can be written as follows. Let's answer exercise 4.7. The federal specific tax on gasoline is 18.4 cents per gallon, and the average state specific tax is 20.2 cents, ranging from 7.5 cents in Georgia to 25 cents in Connecticut. A statistical study found that the incidence of the federal specific tax on consumers is substantially lower than that from state-specific taxes. When the federal specific tax increases by 1 cent, the retail price rises by about 0.5 cents, so that retail consumers bear half the tax incidence. In contrast, when a state that uses regular gasoline increases its specific tax by 1 cent, the retail price rises by nearly 1 cent. So the incidence of the tax falls almost entirely on consumers. In Part A, what are the incidences of federal and state-specific gasoline taxes on firms? The tax incidence on consumers is the share of the tax that consumers pay. The tax incidence on firms equals 1 minus the tax incidence on consumers. From this question, we know that the incidence of federal tax on consumers is 0.5. So the incidence of federal tax on firms is 1 minus 0.5 equals 0.5. The incidence of state tax on consumers is almost 1. so the state tax incidence on firms is nearly zero. In Part B, explain why the incidence on consumers differs between a federal and a state-specific gasoline tax, assuming that the market is competitive. The tax incidence on consumers can be written in terms of elasticities, where dP is the change in price consumers pay, dt is the change in tax, eta is the supply elasticity, and epsilon is the demand elasticity. If the supply elasticity approaches infinity, the tax incidence on consumers approaches 1. This is the case when the state tax increases. The market supply in that state is very sensitive to the price increase due to the state tax because gasoline from nearby states floods into the state. As a result, the tax incidence on consumers is nearly 1. In Part C, using the residual supply elasticity in equation 8.17, estimate how much more elastic is the residual supply elasticity to one state than is the national supply elasticity. For simplicity, assume that all 50 states are identical. Suppose all 50 states are identical. We use the residual supply elasticity equation for identical states. N equals 50. Because epsilon O is the demand elasticity of the other states, and it is negative, we have the relationship that eta R is greater than 50 times eta. It means the residual supply elasticity of the state is more than 50 times the national supply elasticity. Let's jump to exercise 4.8. To reduce population, the California Air Resources Board requires the reformulation of gasoline sold in California. Since then, every few years, occasional disasters at California refineries have substantially cut the supply of gasoline and contributed to temporary large price increases. Environmentalists and California refiners opposed imports from other states, which would have kept price down. To minimize fluctuations in prices in California, researchers suggested setting a 15-cent surcharge on sellers of standard gasoline. In normal times, none of this gasoline would be sold because it costs only 8 cents to 12 cents more to produce the California version. However, when disasters trigger a large shift in the supply curve of gasoline, firms could profitably import standard gasoline and keep the price in California from rising more than about 15 cents above prices in the rest of the United States. Use figures to evaluate the proposal. We can draw the supply curves for the California version of gasoline and the standard gasoline, and then find out the equilibrium in the market before and after the disasters. Without disasters, California's gasoline supply is S1, which intersects with the demand curve at the market equilibrium E1. The market equilibrium price and quantity are P1 and Q1. With disasters, the California version's gasoline supply curve shifts upward to S2. The residual supply facing the state is binding in this case. The new market equilibrium is E2, where the market price P2 equals P tilde plus the surcharge. P tilde is the standard gasoline price in the rest of the United States. The California residual supply from the other states is almost horizontal. It prevents the gasoline price from rising too much in California. Let's solve exercise 4.9. Is the long-run supply curve for a good horizontal only if the long-run supply curves of all factors are horizontal? Explain. The long-run market supply curve is horizontal at the minimum long-run average cost if firms can freely enter and exit the market. An unlimited number of firms have identical costs, and the firm's minimum long-run average cost does not change with the market's total output. It does not require the prices of all the inputs to be constant. As long as the firm's long-run average cost of the output remains the same, the market's long-run supply is horizontal. It allows the prices of some inputs to increase with output, and the prices of other inputs to decrease with output. Let's answer exercise 4.10. Navel oranges are grown in California and Arizona. If Arizona starts collecting a specific tax per orange from its firms, what happens to the long-run market supply curve? The residual supply from California to Arizona is horizontal at P star. The supply is from California. If the demand from Arizona exceeds the supply from California, the supply curve in Arizona becomes horizontal at P star plus T for the rest of the quantity. They are supplied by the local firms. P star is the price before tax, and T is the specific tax. Let's go to exercise 4.11. Draw a figure to illustrate why the size of ethanol processing plants has fallen in recent years. We can draw the short-run and long-run average cost and marginal cost curves in a diagram. When the market price drops to P, the firm's size is larger than the optimal long-run size at that price P. The firm produces QS in the short run, where its short-run marginal cost curve crosses the market price line, and makes a short-run profit equals to the blue area. In the long run, the firm can reduce its size to get more profit. When it produces output QL, where its long-run marginal cost crosses the market price line, it obtains a long-run profit of the gray area, which is larger than the blue area in the short run. That is why the firm's size has fallen in recent years. Let's solve exercise 4.12. The application upward sloping long-run supply curve for cotton shows a supply curve for cotton. Discuss the equilibrium if the world demand curve crosses this supply curve in either a flat section labeled Brazil or the vertical section to its right. What do farms in the United States do? If the world demand curve crosses the supply curve in the flat section labeled Brazil, the market equilibrium is E1. The world market equilibrium price is $1.27 per kilogram. The world market equilibrium quantity includes all the supplies from Pakistan, Argentina, and Australia, and part of the supply from Brazil. If the world demand curve cuts the vertical section, the world market equilibrium is E2. The equilibrium quantity is Q, including all supplies from Pakistan, Argentina, Australia, and Brazil. The equilibrium price is between $1.27 and $1.43. In both cases, the farms in the United States do not supply cotton to the world. Let's find answers to exercise 4.13. In late 2004 and early 2005, the price of raw coffee beans jumped as much as 50% from the previous year. In response, the price of roasted coffee rose about 14%. Similarly, in 2012, the price of raw beans fell by a third, yet the price of roasted coffee fell by only a few percentage points. Why would the roasted coffee price change less than in proportion to the rise in the cost of raw beans? Suppose the price increase in the raw coffee beans is delta T, and the marginal cost of the roasted coffee increases by delta T too. As a result, the market supply curve of roasted coffee shifts upward by delta T. We find the change in the equilibrium price of roasted coffee similar to the analysis of tax incidence on consumers. Because the demand for roasted coffee is downward sloping, the change in the roasted coffee price, delta P, is smaller than delta T. The incidence of delta T on consumers depends on the supply elasticity and demand elasticity. So, the change in the factor price will not be 100% transferred to the price consumers pay. Let's see exercise 4.14. Before the late 1990s, people bought air tickets from a travel agent. When airline deregulation in the late 1970s led U.S. air travel to more than triple between 1975 and 2000, the number of travel agents grew from 45,000 to 124,000. In the late 1990s, internet travel sites entered the market. As a result, travel agents began to disappear. Of those travel agents working in 2000, 10% left in 2001, another 6% in 2002, and 43% by 2010. Use figures to explain what happened in the market for travel agents. Online travel services reduce the demand for traditional travel agents. As the demand for travel agents drops, the demand curve shifts to the left from D1 to D2, and it leads to a decrease in the market equilibrium price from P1 to P2. The market price line shifts downward from P1 to P2. The right graph shows that the firm earns a positive economic profit at P1 because its minimum short-run average cost is lower than the market price. As the market price drops to P2, the firm has to shut down because its minimum short-run average variable cost is higher than the market price now. This is the case of a particular travel firm closed. In the market, there were different travel firms with various average costs and average variable costs. As the market price decreases, those firms with relatively high average costs and average variable costs have to shut down first. That is why we observe travel agents losing their jobs gradually. Let's try exercise 4.15. The long-run cost function of one of the identical carrot-producing firms is as follows. The market demand curve is Q equals 5,000 minus 200 times P. What are the long-run equilibrium price, market quantity, and number of firms? In a competitive market, the long-run market supply curve is horizontal at the minimum long-run average cost. We can solve the problem in 3 steps. First, we find the long-run market supply function. Second, we combine the market supply and the market demand to find the market equilibrium. Finally, we calculate the number of competitive firms that can supply the market equilibrium quantity. In the first step, from the long-run cost function, we obtain the average cost function and marginal cost function. To find the minimum long-run average cost, we use the fact that the marginal cost curve cuts the firm's average cost curve at its minimum. We equate the average cost and the marginal cost functions and get the firm's output at its minimum average cost, which is 50. The minimum average cost is 15. So the long-run market supply is P equals 15. In the second step, combining the market supply and demand functions gives the market equilibrium price of 15 and the quantity of 2,000. In the final step, we calculate the number of competitive firms in the market that supply the market quantity. Since each identical firm provides 50 units of output, the market has 40 firms. Let's finish exercise 4.16. Now, the government starts collecting a specific tax T on the carrot market described in the previous problem. In part A, what are the long-run equilibrium price, market quantity, and number of firms as functions of T? We rewrite the firm's cost function and repeat the same 3 steps as in the previous exercise. In the first step, we find the competitive firm's long-run average cost and marginal cost functions. We use the fact that the firm's marginal cost curve cuts the average cost curve at its minimum to find the firm's minimum average cost. The long-run market supply curve is horizontal at the firm's minimum long-run average cost. In the second step, combining the market supply and demand functions gives the market equilibrium price and quantity. Finally, we calculate the number of competitive firms that can support the market. They are all functions of the specific tax T. In part B, how does the equilibrium market quantity change as T changes? We use calculus to find the answer. The derivative of the equilibrium market quantity with respect to T is negative 200. As specific tax increases by 1 unit, the equilibrium market quantity falls by 200 units. We can also find how the equilibrium market price and the number of firms change as T changes. Thank you so much for solving all the exercises with me today. See you tomorrow in the next section of the chapter. Goodbye. Thank you for watching this video and subscribing to my YouTube channel. See you next time.